Welcome to Maths with EJD. In this video, I move on to talk about multiple angles in trigonometry, multiple angles. And first off, we'll start with the idea of double angles. Double angles. The idea of multiple means that you have more than one, right? Double angles. So what that simply means is that if you have to relate, if you have to relate with the idea of double angle, say you have sine 2a, sine of 2 times of a, you know, previously, right? You remember we talked about sum and difference formulas, and we said that sine a, sine a plus b is the same thing as sine a cos b plus cos A sine B. But in this case, things may be a bit tidier than that because the angles are actually the same in this case. So we can have double angles. So if you have sine 2A, right, it's simply the same thing as sine A plus A. So sine A plus A simply means you have sine A cos A plus cos A sine A, and they're basically the same. So you can, all of that can end up just being 2 sine A cos A straight. So that is sine 2A. So what if you want to talk about, say, okay, let me see what I can use here. Okay, let me go this. So what if you have cos 2A? Cos 2A. Cos 2A is simply cos A plus A. And that means you have cos A minus sine A. And then that goes to be cos squared A minus sine squared A. So if you remember where we started at one of the previous videos, one of the early videos in Trig, if you check, I think first or second video, right? When we talked about trig identities, you will discover that we talked about the fact that something like this, cos squared A plus sine squared A, or if you start with sine squared A, it's also the same, is equal to 1. We talked about this. So since we are dealing in cos, right, we want to put everything here in terms of cos. So in that case, this simply implies that if you need to change sine squared A to be in terms of cos squared, so it means sine squared A is 1 minus cos squared A, right? So here you have cos squared A minus sine squared A is simply 1 minus cos squared A, like we have now. So that means that you have cos squared A minus 1 plus cos squared A. And then that is equal to 2 cos squared A minus 1. So that simply tells you that cos 2A is the same as 2 cos squared A minus A. So that's still that's still talking about the idea of double angles. Of course, like we saw here, right? Sine 2A is the same as 2 sine A cos A. Okay, so the let's talk about tan, right? Tan 2A. Now we already know that tan is sine over cos. And since you already have a pattern for tan itself, you remember that tan A plus B, right, is the same thing as tan A plus tan B all over 1 minus tan A tan B established. Okay. So if that is the case, we can extrapolate, if you like, we can extend the idea to this, and we have tan 2A to be tan A plus A, and tan A plus A, following that idea, would simply be tan A plus tan A, all right, all over 1 minus tan A tan A. If you tidy this up, what do you get? You simply have 2 tan A all over 1 minus tan squared A. And that means that tan 2A is simply 2 tan A over 1 minus tan squared A. So that's the idea of double angle. Okay, let me change the marker colors as we switch to triple angles. Triple angles. What can I go for here? Let me go purple. And then we have this lastly, say we go green. Okay. All right. So now let's talk about triple angles. Triple angles. So things get a bit more complicated, but not totally out of control when we talk about triple angles. So we got just go through the same process, and then like we did with double angle, except that now the process is not as straightforward as what we had earlier. So imagine you're starting with, okay, let me change the marker color here. So imagine you have sine 3a, sine 3a. You can write sine 3a as a plus 2a or 2a plus a. Anyhow you like it, you still get the same result. So sine 3a is sine a plus 2a. So if you go this way, you could also say 2a plus a, and it's okay. So sine a 2 plus 2a is simply the same thing as sine a cos 2a plus cos a sine 2a. Okay. And then you have more work to do now. You have sine a. Cos 2a is the same thing as cos a plus a. All right. Then plus cos a. And sine 2a is actually sine a plus a, like that. And then you try to expand all that. So you have sine a, sine a into cos a plus a is simply the same thing as cos a minus sine a, like we already had, and then cos a here into sine a is sine a cos a plus cos a sine a, right? And then we can tidy things up. So you have sine a into cos a is cos squared a. Sine a is minus sine squared a, like that, plus cos a now into sine a cos a plus cos a sine a is simply 2 cos 2, I mean, sine a cos a is 2, sine a cos a plus cos a sine a is 2 sine a cos a. Okay, so now we can um expand. We can expand. So this is sine a cos squared a is sine a cos squared a. Then the next one, sine a sine squared a is sine cube a plus cos a times 2 sine a cos a. That is 2 sine a cos squared a, like that. And from what we have, right, we can say that sine a, sine a cos squared a plus 2 sine a cos squared a, this and this can go together. So you can have 3 sine a cos squared a minus sine cube a. All right. Now, the issue is, have we actually arrived? Maybe not, because since we are dealing with in sine, we want to probably have everything in terms of sine at the end of the day. So here there's still cos, right? And we know that, so if in that case now we have 3 sine a. So cos squared a is the same thing as 1 minus sine squared a. So this is actually correct if you leave it this way, but we just want to process everything such that at the end of the day, everything is in terms of sine, since we are dealing with sine 3a. So you have 3 sine a into 1 minus sine squared a minus sine cube a minus sine cube a, right? And then this is the same thing as 3 sine a. You have 3 sine a minus 3 sine cube a, like this, minus sine cube a. And then, so this now is, so you can see these two can go together. So you have 3 sine a minus 4 sine cube a, 4 sine cube a. And that is simply what we have for sine 3a. That's the sign of triple angle. That is what you get. So you have sine 3a is 3 sine a minus 4 sine cube a. All right. So there are situations, as you're going to see in the future, there are situations where this kind of expression is easier work with than other forms, especially if you check my videos on complex numbers where I talked about the Morse theorem, you see this playing prominently there, and you can see the connection between trigonometry and complex numbers. Okay, so that's about sine 3a. Let's go talking about cos 3a. Cos 3a. What happens for cos 3a? So for cos 3a, we can say this is cos a plus 2a. And of course, like you know, this is cos a cos 2a minus sine a sine 2a. And if that is the case, that means we have cos a into cos a plus a, and we have minus sine a into sine a plus a, right? And then this is equal to cos a now into cos a, that's cos squared a minus sine squared a, like we already know. Then minus sine a now into sine a, you know that sine a cos a plus cos a sine a, which is simply the same thing as 2 sine a cos a. Now I've jumped like one step because we've done that several times. So we can expand now. We get cos cube a minus sine squared a cos a. Then here we multiply sine a to sine a cos a. That is 2 sine squared a cos a. And then we get cos cube a minus 3 sine squared a cos a. And since you are dealing with cos, right, it's better to put everything in terms of cos. So let's go doing cos. Let's see how that works. So we have cos cube a now minus 3. Sine squared a is 1 minus cos squared a. Then all of that multiplied by cos a. So, so now we have cos cube a minus 3 times 1 cos a. It's more like, imagine that cos a is right here. So you have 3 times cos a times 1, that's 3 cos a. The minus times minus is plus, and we have 3 cos cube a. Okay? So cos cube a, 3 cos cube a is 4 cos cube a. So you have 4 cos cube a minus 3 cos a. And that is what cos 3a ends up as 4 cos cube a minus 3 cos a. So still talking about triple angle, whatever we do for sine and cosine, we have to do for tan. So let's go doing tan 3a. So for tan 3a, what do we get? We have tan 3a. Interestingly, we already know the pattern for tan, so we can go for that. So we know tan 3a can be tan a plus 2a, tan a plus 2a. So we can actually go the sine over cos route, but in this case, since you already know the pattern for tan, we can actually follow the pattern. So this will be tan a plus tan 2a all over 1 minus tan a tan 2a. Okay? And if that is the case, that means we have tan a plus tan a plus a, tan a plus a, and all that is over 1 minus tan a, multiplied by tan a plus a. So we expand that all the sides where we have tan a plus a. So we have tan a plus, of course, tan a plus a again, that's of course, like we know, that is 2 tan a all over 1 minus tan squared a, like that. So of course you can take this as tan a over 1 to make all of them look a bit alike. So what do we have? So again, this is 1 minus tan a into 2 tan a, 2 tan a, all over 1 minus tan squared a, like we already know. And then we can put everything together. Of course, now we see an LCM here. The LCM is 1 minus tan squared a. So so by multiplying every term through by 1 minus tan squared a, we get rid of fractions wherever they exist. So here we have tan a into 1 minus tan squared A, then plus 2 tan A all over 1 minus tan squared A multiplied by 1 minus tan squared A. 1 minus tan squared A, right? So, if you like, you can put that over 1. All over 1 on its own multiplied by 1 minus tan squared A. This go together, just like this go together, and this go together. So minus tan A into 2 tan A all over 1 minus tan squared A multiplied by 1 minus tan squared A. So now things will get easier beyond this point because this cancels this cancels this. So we have so we can have uh we have now tan A into 1 minus tan squared A plus here now you have 2 tan A and you are free from the burden of the numerator. And here we have 1, so we have 1 minus tan squared A because 1 multiplies that minus tan A into 2 tan A. Okay, things look a bit tidier and we are almost going to say uhuru. Okay, so the next thing we have tan A, if you multiply this and this, minus tan cube A plus 2 tan A. Okay, then we have 1 minus tan squared A minus 2 minus 2. That's tan A times 2 tan A. That's 2 tan squared A. And then this and this can go together. So you have 3 tan A, minus tan cube A all over 1 minus 3 tan squared A. And that is the end of that long episode. So it means that tan 3A is this long expression. Well, I mean, it's tidier, right? Because everything is all about A, except that it is now triple. So that is tan 3A for you. And like I said, as we're going to see in future work, that sometimes it is necessary to be able to express things like this for uh for you to be able to solve some problems. So you want to go through all this and be sure you can actually handle them yourself. So that is the end of multiple angles as far as trig is concerned. So you can actually extend this whole idea to quadruple angle, maybe less than 4a sine 4a cos 4a. You can take it to as high as you want. And of course, when you get very high multiples like that, the Morph's theorem comes in handy to take care of things like that. So if you have not seen my videos on complex numbers, you want to check them out. I might also be able to put the link in the description for this particular video. I guess I hope I remember that. So, but if not, remember, check under complex numbers and see De Morph's theorem and how they are connected with trigonometric ratios. All right, so that is the end of this video. Thanks for listening. If you have not subscribed, be sure to do that. Make sure you hit the notification bell so you can always get alerted each time I upload a video. And don't forget to like, comment, and share so that you can always have your maths problems simplified. Thanks for listening. See you in the next video.